bottom line, I simply want to make ever better car, no matter what kind of the powertrain they have.
Imagine waking up to a world in which non-electric vehicles are the most popular option for environmentally friendly mobility. What if a single technology advancement completely changed the electric vehicle business and opened the door for a more effective, cleaner alternative? Through the company's innovation in hydrogen engine technology, this is no longer just a pipe dream. This new engine will end electric cars, says Toyota CEO about his creation. What if the race for sustainable transportation took an unexpected turn? Could a groundbreaking technology dethrone electric vehicles as the clean mobility leader? Join us as we explore the innovations announced by Toyota's CEO that will reshape the future of transportation. The leaders in the sustainable transportation race, China and the United States, two titans at the vanguard, are fiercely vying for control of the future of the world auto industry. Dominating conventional internal combustion engines is only one aspect of the competition. More importantly, the goal is to lead and pioneer the market for electric vehicles and other clean energy alternatives, such as automobiles that run on hydrogen or water. Both countries' routes to sustainable transportation offer different opportunities and challenges, despite the fact that they have made significant strides in manufacturing, innovation, and technology. Over the past 10 years, China has overtaken traditional automotive giants like Japan, Germany, and the US to become the world's largest producer and consumer of electric vehicles. This quick climb is no coincidence. China's government, which saw early on the economic and environmental advantage of lowering reliance on fossil fuels, has vigorously promoted measures meant to promote a healthy EV industry. China's dominance in the EV sector is due in large part to the rapid rise of homegrown companies like BYD, NIO, XPeng, and Li Auto. With their modern designs, cutting-edge technology, and extremely reasonable prices, these businesses have captivated customers not only in China but also globally. Due to the rapidly increasing demand for clean energy vehicles in Southeast Asia and Europe, Chinese manufacturers are concentrating more on these markets. Europe has proven to be a profitable market for Chinese EVs because of its stringent emissions regulations and vigorous green energy initiatives. For instance, NIO and XPeng have both launched models in Norway, one of the most EV-friendly countries in the world. China has also used its superiority in battery manufacturing to establish a solid foothold in the global EV supply chain. With firms like the largest battery producer in the world, contemporary Amperex Technology Cooperation Limited, KTL China, has a major competitive edge in this crucial EV manufacturing sector. Chinese EV manufacturers still face barriers when they go global, despite these achievements. The competition from well-established automakers' quality control and brand perception continue to be major obstacles. But with a well-stable local market, robust government support, and a defined transportation goal, China is well positioned to continue leading the world EV industry. Car titans like Ford, General Motors, and the innovative Tesla, the US, has adopted a distinct strategy in the market for electric vehicles. In contrast to China, which has prioritized mass production and government assistance, the United States has focused on innovation, market disruption, and customer demand. Particularly, Tesla has significantly influenced the worldwide EV market by establishing benchmarks for electric vehicle performance, range, and design. Both China and the United States are deeply committed to the future of electric vehicles, but their strategies and focus areas differ significantly. China's strategy is based on industrial strategy and government policy, whereas the US approach is driven more by consumer demand and innovation assistance from the government. The expansion of the EV market in China has been greatly aided by the government. Subsidies, tax incentive, and strict emissions regulations have encouraged both automakers and consumers to embrace electric vehicles. China's Made in China 2025 initiative explicitly targets the development of EVs and other clean technologies, with the goal of becoming a global leader in these sectors. The United States government, on the other hand, has adopted a more detached stance, though this is starting to shift. With plans to make significant investments in EV infrastructure, such as charging stations, and provide incentives to customers who purchase electric cars, President Joe Biden's administration has made sustainable energy and electric vehicles a top priority. But the United States continues to trail behind China in terms of government support for electric vehicles. As the world accelerates its search for greener solutions, could hydrogen-powered cars emerge as the breakthrough that surpasses both gasoline and electric vehicles? Let's dive in and find out. Vehicles powered by water. The fact that hydrogen-powered vehicles emit no pollutants when in use is one of its most prominent benefits. Hydrogen fuel cell vehicles only produce heat and water vapor as byproducts, as opposed to petrol engines that discharge dangerous pollutants such as carbon dioxide (CO2), nitrogen oxides (NOx), and particulate matter. As a result, compared to traditional internal combustion engine ICE vehicles, which are a significant contributor to air pollution and global warming, hydrogen-powered vehicles offer a more environmentally friendly choice. Hydrogen fuel cells generate power by combining ambient oxygen and hydrogen gas through an electrochemical process. It is a clean, efficient, and completely emission-free process because there is no combustion. The environmental benefits of hydrogen-powered cars are becoming increasingly significant as governments around the globe tighten pollution regulations and search for ways to mitigate climate change. The time it takes to refill or recharge a hydrogen-powered car is a significant advantage over a battery electric vehicle. Similar to filling up a petrol tank, hydrogen fuel cells may be refueled in a matter of minutes, making them a more convenient choice for customers used to the efficiency and speed of petrol station refueling. Charging the battery of an electric vehicle can take anywhere from 30 minutes using a fast charger to several hours using a standard charger, depending on the battery size and the type of charger. This quick refueling capability gives hydrogen-powered cars an edge, especially for long-distance travel or commercial applications where time efficiency is critical, such as for buses, trucks, or fleet vehicles. Due to its ability to refuel quickly without compromising range, hydrogen is a more practical option for industries where downtime is costly. Another significant benefit of hydrogen-powered vehicles is their longer driving range. Depending on driving conditions and fuel storage capacity, a typical hydrogen vehicle, such as the Toyota Mirai, can travel 400 to 500 miles, which is on par with or even greater than that of many gasoline-powered vehicles. In addition, battery electric vehicles typically have a range of 200 to 300 miles, with high-end models, such as the Tesla Model S, reaching up to 400 miles under ideal conditions. However, as battery range decreases with heavy use, temperature fluctuations, and the need for air conditioning or heating, hydrogen-powered cars offer a more consistent long-range alternative. Because of this, hydrogen fuel cell vehicles are especially well-suited for areas with inadequate infrastructure for charging or for customers that require a vehicle for lengthy travels. Vehicles that run on hydrogen have the scalability and adaptability to be used in a range of situations. Hydrogen technology may be used for a variety of vehicle types, including buses, trains, airplane, and commercial trucks, while electric vehicles are best suited for smaller passenger cars. The use of hydrogen in larger vehicles, such as buses and long-haul trucks, is particularly promising because of the fuel's energy density. Besides the automobile industry, other industries that can use hydrogen fuel cells include stationary power systems material, handling devices like forklifts, and backup power generation. Because it provides a comprehensive clean energy solution, this versatility makes hydrogen technology more appealing in a variety of sectors, including logistics, public transportation, and aviation. The use of hydrogen as a fuel could significantly reduce the global dependency on fossil fuels. While BEVs offer a means of reducing reliance on fossil fuels, hydrogen is an alternative, complementing choice, especially in regions with a high concentration of renewable energy. Green hydrogen can be used as a sustainable and carbon-neutral fuel substitute when it is electrolyzed utilizing renewable energy sources like solar, wind, or hydropower. In contrast to petrol, which comes from limited and environmentally harmful fossil fuels, Hydrogen is the most prevalent element in the universe and can be created from a number of resources, such as biomass, natural gas, and water. Even though natural gas still make up a significant amount of hydrogen generation today, green hydrogen production is becoming more feasible and economical. Hydrogen-powered cars can help countries diversify their energy sources and increase energy security by reducing reliance on petroleum and natural gas. Hydrogen can be used to store excess renewable energy generated during peak production periods, which can then be converted back into electricity when needed, thus stabilizing the grid. Hydrogen's role as an energy storage solution enhances its value as part of a broader clean energy ecosystem. Hydrogen-powered cars are a progressive, long-term way to reduce transportation's impact on the environment as the globe moves more and more in the direction of conservation. Hydrogen technology provides a means of reaching the aggressive net-zero emissions targets being set by governments worldwide, all the while preserving the practicality, range, and flexibility of existing gasoline-powered automobiles. And as hydrogen-powered vehicles are well positioned to overcome the drawbacks of battery electric vehicles, namely with regard to range anxiety, charging infrastructure, and battery deterioration over time, hydrogen guarantees that the automobile sector is not exclusively dependent on battery technology by delivering a clean energy alternative, opening up more options for attaining a future that is environmentally friendly. The road to broad acceptance comes with difficulties, regardless of the potential of hydrogen-powered automobile as a green replacement for petrol. Are barriers to the future of environmentally friendly driving too great, ranging from safety concerns to the high price of infrastructure? Problems with water-powered vehicles? Even though there are many benefits to hydrogen-powered cars, there are drawbacks as well that must be resolved before they can be widely used. As the technology advances, owners of hydrogen-powered vehicles need to be aware of these restrictions and figure out how to lessen or go around them. Although many of the problems associated with storing and transporting hydrogen have been mitigated by safety technological developments, public perception remains a challenge due to the potentially flammable nature of hydrogen. Safety concerns have persisted due to hydrogen's explosive qualities, as well as previous incidents like the Hindenburg tragedy. Using state-of-the-art materials and storage method, new hydrogen-powered vehicles are designed with safety in mind to minimize the chance of leaks or explosions. By properly maintaining their vehicles and according to recommended safety protocols, owners of hydrogen-powered vehicles can alleviate concerns over safety. Safety requirements are always being improved by manufacturer and regulators to ensure that hydrogen vehicles meet or exceed industry safety standards. Among the world's leading automakers, Toyota is unique in its leadership in hydrogen technology. Other manufacturers, such as Tesla in the US and BYD in China, have mostly focused on battery electric vehicles, while Toyota has remained committed to the development and marketing of hydrogen fuel cell vehicles as an essential component of its long-term sustainability plan. Thanks to its cutting-edge battery technology and autonomous driving features, Tesla has emerged as the market leader in the U.S. electric vehicle market. Under the Biden administration, the United States government has also made large investments in electric vehicle infrastructures, with plans to encourage the shift to clean energy vehicle and construct a nationwide network of charging stations. Instead of focusing on controlling the electric car sector like China and the US do, Toyota's decision to prioritize hydrogen suggests a different approach that tries to address some of the limitations of battery technology while offering a complementary clean energy solution. The environmental impact of petrol and hydrogen engines is the main distinction between them. In which petrol engines consume fossil fuels, they produce particulate matter, nitrogen oxides, NOx, carbon dioxide CO2, and other dangerous pollutants into the atmosphere. These pollutants worsen air pollution, climate change, and public health issues. Furthermore, hydrogen fuel cells do not produce any emissions when in use, and it's crucial to remember that the advantages of hydrogen for the environment rely on the method of production. Green hydrogen, which comes from renewable energy sources, is carbon neutral, whereas gray hydrogen, which comes from natural gas, still releases some carbon dioxide. The efficiency of petrol engines is rather low when compared to hydrogen fuel cells. Normally, internal combustion engines, ICEs, only transform 20 to 30% of the energy contained in petrol into useful power. The remainder is lost as heat. One efficient method of converting energy into power, however, is through hydrogen fuel cells, which can achieve an efficiency level of 50 to 60%. Although they have the good of quieter and smoother operations, hydrogen fuel cells cars perform similarly to gasoline-powered vehicles in terms of acceleration and driving dynamics. Since hydrogen fuel cells generate electricity to power an electric motor, FCVs provide a driving experience similar to that of battery electric vehicles, with instant torque and no engine noise. Currently, gasoline-powered cars are more affordable than hydrogen vehicles, both in terms of the initial purchase price and fuel costs. Hydrogen vehicles, such as the Toyota Mirai, are still relatively expensive due to the high cost of producing hydrogen fuel cells. The infrastructure for gasoline-powered cars is well established, with gas stations available in nearly every part of the world. In contrast, hydrogen refueling stations are still scarce, particularly outside of major urban areas. Expanding the hydrogen refueling network will be critical to the widespread adoption of hydrogen-powered cars. Early 19th century beginnings. It may surprise you to learn that the origins of hydrogen-powered vehicles can be traced back to the early 1800s, when motorized transportation was still mostly a pipe dream. When Swiss inventor François-Isaac de Rivaz produced the first internal combustion engine powered by hydrogen and oxygen in 1806, he achieved a significant accomplishment. The first attempt to use hydrogen as a possible energy source for a vehicle was de Rivaz's innovation, albeit rudimentary. Although his experimental engine was not yet feasible, it was a first step towards the potential of hydrogen as fuel. In 1807, de Rivaz built a crude vehicle using his hydrogen-powered engine to further refine his idea. It demonstrated that hydrogen could be used as an energy source for mechanized transportation, despite its awkwardness and inefficiency. This early testing suggested that cars might eventually run without traditional fossil fuels. De Rivaz's idea laid a vital basis for succeeding engineers and scientists to build upon, even though it was not a financial success. French inventor Étienne Lenoir, who was born in Belgium, developed de Rivaz's initial hydrogen-powered engine design in 1860. Following years of testing, Lenoir was able to develop a more dependable internal combustion engine that was the first to run on a combination of ambient air and hydrogen. His engine, dubbed the Hippomobile, was a significant advancement over earlier models. His design proved that hydrogen could be utilized as a practical fuel alternative, even though it was still inefficient when compared to later petrol engines. Records from that period reveal that in 1863, Lenoir achieved a milestone by successfully powering a carriage with his hydrogen-based engine. Hydrogen was positioned as an early contender in the quest for sustainable transportation, which was especially noteworthy considering that gasoline-powered engines had not yet taken primacy. Nevertheless, issues with energy efficiency and storage have prevented the widespread use of hydrogen-powered vehicles. As a result, in this age, hydrogen vehicles remained primarily experimental and never became commercially viable. The Soviet Union's fuel constraints during World War II brought hydrogen power back into the spotlight. The USSR demonstrated the potential of hydrogen as an alternate fuel for emergencies by starting to modify trucks to run on hydrogen gas. The Soviet Union's hydrogen trials showed the fuel's adaptability by offering a short-term fix for the acute petrol shortages that afflicted the Eastern Front throughout the conflict. Hydrogen's role as a backup fuel during time of scarcity was reinforced by this wartime breakthrough, which demonstrated its viability as an emergency resource. A major advancement in hydrogen vehicle research was made in the United States by hydrogen technology pioneer Roger Billings. An important turning point in hydrogen technology was reached in 1966 when Billings successfully converted a conventional automobile to run on hydrogen. Automakers, governments, and academia all took notice of his work, which sparked a surge in interest in and research into hydrogen-powered cars. Billings was not alone in his quest. General Motors also explored hydrogen technology. In the same year, GM launched the Electrovan, the world's first hydrogen fuel cell vehicle. Even though the Electrovan project was revolutionary, it was eventually abandoned because of the enormous expenses and the technological difficulties involved in storing and distributing hydrogen. The potential of hydrogen as a clean, renewable fuel source was nevertheless highlighted by Billings and General Motors' early experimental efforts in hydrogen mobility. A fresh interest in alternative fuel was sparked by the energy crisis of the 1970s, which had a significant impact on global energy policy. The oil embargo brought attention to hydrogen as a viable, long-term fossil fuel substitute. Continued research by Roger Billings led to the successful testing of a hydrogen-powered pickup truck in 1972, proving that hydrogen could be used for daily transportation. Billings' work contributed significantly to the conceptual understanding of hydrogen storage, distribution, and safety, encouraging further research into the technology's potential. Germany and Japan emerged as leaders in alternative energy during this time. In 1979, both nations invested in hydrogen vehicle research, creating the foundation for government-backed hydrogen initiatives. By focusing on hydrogen's potential, Germany and Japan helped propel hydrogen technology into the next phase, paving the way for more focused research in the coming decades. Their investments reflected a growing consensus that hydrogen, as a clean fuel, could alleviate dependency on imported oil. Developments during the 1990s and the first part of the 2000s. Global automakers started to consider hydrogen technology seriously by the late 1990s. Automakers searched for methods to lower emissions as environmental consciousness increased and pollution laws became more stringent. Because hydrogen fuel cells can generate power through a chemical reaction with just water's vapor as a byproduct, they have emerged as a promising solution. The dawn of the 21st century ushered in a new era for hydrogen vehicles, with significant investments in fuel cell technology from both private companies and government organizations. Honda demonstrated its commitment to hydrogen technology in 1999 with the release of the FCX, a hydrogen fuel cell car prototype. Competition in the industry increased when Toyota introduced the fuel cell hybrid vehicle in 2002. With the implementation of policies and supportive infrastructure to encourage the adoption of hydrogen, California emerged as a key proving ground for these cars. The excellent performance of these fuel cell vehicles indicated that hydrogen has a promising future and showed promise as a practical, emission-free alternative to gasoline-powered cars. The development of hydrogen vehicle from the 1800s to the present signifies a significant change in the way society views environmentally friendly transportation. Contemporary fuel cell automobiles like the Honda Clarity and Toyota Mirai can generate over 100 kilowatt of electricity, enabling driving ranges that are on par with those of conventional gasoline-powered vehicles. The fact that these cars may be refueled in a matter of minutes is a significant advantage over battery electric vehicles, which require longer charging times. Future energy and transportation systems will be significantly impacted by hydrogen's scalability and adaptability as an energy carrier. Because of their great versatility, fuel cells can be utilized in stationary uses like grid energy storage or building backup power in addition to automobile. With over 50 hydrogen refueling stations in California alone, hydrogen infrastructure is still growing and is expected to spread throughout the world, particularly in hydrogen-forward nations like Japan and Germany. Is Toyota's hydrogen vision the future of clean transport? Will hydrogen fuel cells reshape mobility? Let's find out. Toyota's audacious vision. Toyota has cemented its position as a leader in hydrogen fuel cell technology at a time when the global automotive industry is changing due to the urgent need to address climate change and make change to more environmentally friendly modes of transportation. When the CEO began speaking, the audience became silent because they were so focused on his words. Toyota emphasized Toyota's steadfast dedication to hydrogen as a sustainable energy and transportation solution. Hydrogen is not just the fuel of the future, he stated. It is the fuel of today, and we are ready to lead the world into a hydrogen-powered era. Speaking passionately about Toyota's role in forming a global hydrogen economy, the CEO emphasized the significance of industry and governmental cooperation in establishing hydrogen as a common energy source. The audience reacted with enthusiasm, with many industry leaders expressing optimism about Toyota's ambitious plans. Toyota's speech reinforced the notion that Toyota is not simply reacting to current trends, but is actively shaping the future of sustainable transportation. His bold declarations were met with applause as he outlined the company's strategy for expanding hydrogen applications beyond the automotive sector. Toyota's dedication to this clean energy solution is a bold vision for the future of transportation and beyond, spearheaded by visionary leaders like Executive Vice President Masahiko Nakajima. Toyota's steadfast faith in hydrogen's potential as a game-changing energy source has been expressed by Nakajima, one of the major players in the company's strategic direction. Expanding the usage of hydrogen technology beyond passenger cars is Toyota's long-term objective. The Toyota Mirai, the company's flagship hydrogen-powered vehicle, has already made major progress, but its goals are considerably higher. Toyota is making a concerted effort to extend the usage of hydrogen technology to other modes of transportation, such as buses, trains, trucks, and even boats. The company sees hydrogen as a means of decarbonizing not only road transport, but also sectors like heavy-duty goods, shipping, and aviation, where electrification would not be as feasible or effective. According to Nakajima, Toyota is eager to use hydrogen technology in fields that have historically relied significantly on fossil fuels, including as industrial applications and power generation. This is in line with a broader vision where hydrogen could power companies and homes alike and establish itself as a key element of a global clean energy system. Beyond producing cars, Toyota demonstrates a broader commitment to creating an environment where hydrogen is crucial to reducing global carbon emissions and altering the energy landscape. One of the most interesting aspects of Toyota's hydrogen strategy is that the corporation sees hydrogen as much more than just a vehicle fuel. Toyota is applying its understanding of hydrogen to enhance many forms of transportation, including buses and trains, as well as industrial equipment, such as stationary power generators and forklifts. In fact, hydrogen technology is being researched to power aircraft and even ships. This diversification into other industries demonstrates the adaptability and scalability of hydrogen fuel cells, which makes them a vital component in initiatives to decarbonize sectors other than transportation. Toyota's focus on hydrogen is particularly significant in regions where electricity grid stability is a concern. Hydrogen can be produced and stored when renewable energy is abundant, such as during periods of high solar or wind generation, and then used to generate electricity when demand peaks or renewable generation dips. This reflects Toyota's broader commitment to ensuring energy resilience and sustainability, especially in areas that are facing increased pressure to reduce emissions from both transportation and industrial operations. Toyota is not content with simply deploying hydrogen technology. It is actively working to make this technology more accessible and affordable. A major goal for the company is to reduce the cost of hydrogen production, storage, and distribution. This will not only make hydrogen-powered vehicles more competitive with battery electric vehicles and gasoline-powered cars, but also accelerate the adoption of hydrogen in a range of industries. One of Toyota's main strategies to do this is to focus on making its fuel cell systems more efficient overall. For instance, compared to previous generations, fuel cell stacks equipped with Toyota's latest advancements in hydrogen technology offer a 20% increase in power density and a 30% cost reduction. These developments have the potential to significantly lower the cost of hydrogen-powered vehicles, making them more attractive to consumers and businesses alike. At the same time, Toyota is having trouble meeting the obligation to reduce the carbon footprint associated with the manufacturing of hydrogen. To do this, the company is investing heavily in green hydrogen technologies, which eliminate the need for natural gas by producing hydrogen using renewable energy sources like solar and wind. Improving the entire hydrogen supply chain, including infrastructure for production, storage, and transportations, is another important area of interest for Toyota. Toyota wants to make sure that hydrogen can be produced and transported wherever it is needed by establishing a more efficient and integrated hydrogen ecosystem. The company's strategy involves working closely with energy companies, governments, and industry partners to build the infrastructure necessary to support a hydrogen economy on a global scale. Toyota is changing mobility in a sustainable, low-carbon future with its hydrogen technology innovations, which go beyond simply producing better automobiles. According to the business, hydrogen has the potential to revolutionize how we move, power our daily activities, and engage with our surroundings. With Toyota positioning itself as a pioneer in sustainable energy innovation across numerous industries, this goal transcends the conventional role of automakers. When Toyota CEO Akio Toyoda took the stage to give a keynote talk at a recent industry event, the excitement surrounding Toyota's leadership in hydrogen peaked. The company's next moves in its hydrogen journey were eagerly anticipated by the attendees, and Toyota did not let them down. Even though Toyota is at the front line of hydrogen fuel cell technology, the corporation is well aware of the obstacles that need to be removed before hydrogen can become a widely used energy source. The price of creating hydrogen, constructing refuel facilities, and guaranteeing a dependable supply chain continue to be major challenges, as Nakajima noted. However, Toyota is optimistic that with continued innovation and collaboration, these challenges can be addressed. One of Toyota's major goals is to bring down the cost of hydrogen production and make green hydrogen the most sustainable form of hydrogen more economically viable. In order to lower the cost of the materials used in fuel cells and increase the efficiency of electrolysis, the process that turns water into hydrogen, the company is spending money on research and development. Toyota is also committed to enhancing a long duration and efficiency of its hydrogen fuel cells. The company's latest fuel cell technology offers a 20% increase in power density and a 30% reduction in cost compared to previous generations, which can significantly accelerate the adoption of hydrogen-powered vehicles. Toyota is also exploring ways to reduce the carbon footprint of its manufacturing processes. By incorporating renewable energy into its production facilities and sourcing sustainable materials for its vehicles, Toyota aims to create a more environmentally friendly supply chain. This holistic approach reflects Toyota's broader vision of sustainability, where hydrogen is not just a fuel for cars, but a key part of a cleaner, greener future. As it keeps pushing the limits of hydrogen technology, Toyota is establishing itself as a pioneer in clean energy innovation worldwide. Other automakers might be more concerned with battery electric cars, but Toyota's dedication to hydrogen shows a progressive mindset that seeks to solve the problems of energy storage, grid stability, and decarbonization globally. Toyota has a big plan for a hydrogen-powered future, but considering its track record of innovation and leadership in the sector, it seems likely to achieve its goals. Toyota is helping to shape a future where hydrogen plays a significant role in the global energy and transportation systems by investing in hydrogen fuel cell technology and expanding its application outside the automotive sector. Toyota's audacious hydrogen ambition will surely influence the direction of sustainable mobility as the automotive sector develops more. Finally, Toyota is setting the standard for a cleaner, more sustainable future for generations to come, whether through its flagship cars like the Toyota Mirai or its initiatives to create a worldwide hydrogen ecosystem. Please subscribe to our channel, leave a comment, and like this video if you would want to receive more updates. While you're still here, click the video to view more amazing videos.